Okay guys, I'm going to have a look at what should be the last video for the last section in your specification 2.6.10 to 2.6.11 which is the last part of your moles calculations for GCSE Unit C2 chemistry. And this topic is a small one, but it's entitled percentage atom economy. Now, I've written up here, and it's in your notes as well. Probably a good idea if you went to your notes. I think it's the start on page 20 of your class notes. Runs through to page 21, and when I'm finished there are some questions on page 20 and 21 which you can also use. Probably a good idea actually if you do those as practice, and the answers to those I have either sent you on Firefly or I can send them on Firefly. One way or the other, you can get them. Right, so this is the formula, and they may well ask you in an exam just what is percentage. AE is atom economy, obviously, and it is the RFM of your desired product divided by the total RFM of all of your products. And we'll look at what sort of a desired product is and what all of the RFM of all the products is, although that's pretty self-explanatory. Now, if you remember back in year 11, you did another percentage calculation with regards to moles, and that was your percentage yield. Now, your percentage yield just really worked out what percentage of your reactants were actually converted into products. It didn't actually take into any account whether you wanted all of those products or not. Because if there's certain products that you don't want and there's nothing you can do with them, well, then those products may actually be quite wasteful. Or they may just be waste, and if you produce waste in any industry, you've got to dispose of that waste, and certainly within the chemical industry, disposing of waste can be expensive. Okay, so that's a bit of an issue. We really don't want to be carrying out reactions which produce lots of waste, because that costs money. The other problem with waste, and it doesn't apply in this instance, but you might be talking about things that are environmentally negative. Okay, so you might have things that are environmentally negative, then they may cause big problems with regards to disposal of them and processing the disposal of them. So the other environmental aspect of any process is which we can't tell from a chemical reaction, is the amount of energy that is used, because energy itself uses fossil fuels. So if you're running a process at a high temperature or a high pressure, you're going to be using a lot of electricity and a lot of energy to do that, and that is an environmental negative in itself. Catalysts are being used extensively to reduce the amount of energy and also to change pathways of chemical reactions so that maybe we don't produce wasteful products as we do it. The other thing that you need to consider when they're talking about the environmental friendliness and the environmental sustainability of a chemical process is, where do these things actually come from? So lots of raw materials come from mining. Some of them come from quarries. Okay, some of them come from wells, like oil wells deep under the ocean, and those themselves have their own environmental issues. Obviously, quarrying, you're digging big holes in the earth, and they're fairly unpleasant. They're quite dangerous. Oil, and obviously the raw materials have to be transported from there, which creates noise and dust, uses diesel and fuel, and produces all the negative gaseous products caused by lorries and ships and everything moving around the countryside and the world in general. So there's a lot of things coming into play when we're talking about the environmental sustainability of chemical reactions, not just byproducts and waste. But let's go back to the percentage yield and what percentage yield actually tells us. So percentage yield just tells us really what percentage of our reactants get turned into all products. Okay, so let's take for example this reaction here. Percentage yield is the actual mass of a product divided by the theoretical mass. In other words, how much did you actually make in your reaction divided by how much should you actually have made based on 100% yield if all of these were converted to this. I've just taken a very simple example here where I've taken 5 grams of iron hydroxide has been made, and I actually theoretically, based on the amount of reactant that I started off with, I should have made 6. That gives me an 83% yield, and that seems like a reasonable yield, and that seems okay. But let's say the other product here is waste. Now it's sodium chloride, I know, and sodium chloride is not a big issue in terms of waste, but let's imagine that it's an environmentally negative waste, and it costs my company a huge amount of money to deal with and process and get rid of. So if I go back up here to my percentage atom economy, and I was to do a percentage atom economy calculation for this particular process, I would say my desired product is my iron hydroxide. Okay, so that's the one that I'm after. Desired product is the one that I could sell, make money off. Okay, so that is 56 plus 2 hydroxides are 34. Okay, now there's no stoichiometric, there's no number here, so I don't need to multiply it up by anything. I just keep that as 1. And then I divide that by the total RFM of all the products. So sodium chloride is 23 plus 35.5 for your chloride. Okay, so that's 58.5, but I've got to multiply that 58.5 by 2 because I've got to remember there's 2 of those produced. Okay, and that's plus the 56 and the 34. So that gives me, on the bottom line, 207. Okay, so just do that calculation. That gives me a percentage atom economy then of 43.5%. So whilst I might have had an 83% yield in this particular reaction, okay, my percentage atom economy is only 43.5. Now what that's telling me is that 43.5 of my reactants are turned into useful product. In other words, about roughly 56.5% of my reactants in this particular reaction are actually waste. Okay? Now this is where your chemical engineers and your research and your development come into play, where what they want to do now is change this process to make this into a process where there's no waste. Alternatively, what they could do is find a use for the sodium chloride. And if I could find a use for the sodium chloride, well then how will that affect my atom economy? Well, that is now a desired product. So I now have 2 desired products, and my atom economy goes up to 100%. Okay, but you can't often find uses for many of the byproducts in the chemical industry. That'll be sort of an ideal situation. So I've talked you through there how to do it. I've talked you through sort of the comparison between it and percentage yield. I've talked you through all the other sort of considerations that you need to be aware of whenever you're deciding on how wasteful or how sustainable a chemical process is. It's not just about your percentage atom economy, it's about how environmentally damaging your other products are. It's about how much energy your process makes. It's about where do your raw materials actually come from. All those sorts of things. Okay, so we'll do a few calculations on your percentage atom economy, and then it'll be over to you guys to do the questions on page 20 and 21. So we'll keep that up. These are not very difficult, so we'll only do 2 or 3 calculations on them, guys, and then it will be it'll be over to right. Okay, so let's say I am looking at a reaction between let's